High-side switch introduction. In this section, we will discuss the fundamental idea behind Texas Instruments high-side switches. What are high-side switches? High-side switches are any switch that is placed between the power source and the load. By definition, they are then placed on the high side of the load. High-side switches control the flow of power from the source to the load. And in solid-state systems, this is conventionally achieved by driving an NFET heavily into the linear range of operation. Please note that TI high-side switches are built for DC applications. Fast PWM applications may not be achievable with high-side switches. Often, in applications using high-side switches, the load is placed at a distance away from the switch. This happens when there is a centralized controller while the load is further downstream. This presents challenges in terms of load driving and protection, which we will get into in future sections. Applications for high-side switches are found in both the automotive as well as industrial sectors, but it is not uncommon to see applications existing in other systems like communications equipment or perhaps even some unique personal electronic systems. High-side switching versus low-side switching. Another method of controlling power to a load is by disconnecting the load from ground. This is low-side switching. This is contrary to high-side switching, which instead disconnects the load from the source. Often, high-side switching is preferred because in a low-side switching system, the load is always active or powered. Therefore, in the event of a dropped wrench or frayed wires, it is easier to mistakenly complete a circuit that is using low-side switches. Please note that this does not mean that there is no place for low-side switching in the industry. This is because there are major challenges when using high-side switches. One major challenge is that NFETs are often preferred for high-side switches due to their smaller size and low R-on capability. But to achieve a low R-on, the gate voltage has to be driven significantly higher than the source voltage. Another challenge is during inductive load driving. When an inductive load is turned off, a large negative spike can exist on the output rail of the high-side switch. We will discuss more about inductive load driving in future sections. So what are TI high-side switches? TI high-side switches are integrated solid-state devices that combine both the power FET and the gate driver into one device. Integration leads to significant benefits because we can integrate both protection features as well as diagnostic features into the same device. This allows for one device to be a solution for many applications. Another integrated protection feature is an integrated internal clamp which allows for safe off-board load driving. Efficient packaging leads to better thermal performance, and different devices within the same family have different on resistance which target different applications. It is easy to design and lay out your board with TI high-side switches. This is because evaluation modules are provided for every device, which allows example designs that can be reused and modified as needed. Families of devices exist which allows for significant reuse of design depending on the power level of the application.